We're back to the review. Number 17, we want to find the slant asymptote for the equation. So we know we have a slant asymptote when we look at the very first terms and we see that the exponents, the upper exponent, which we call n, is greater than the bottom. When we do that, we have no horizontal. We only have a slant asymptote, and we do that by dividing the numerator by the denominator. I'm going to do my work here under number 18 for just a moment. We have 3x squared minus 5x plus 1, and we want to divide that by the denominator, which is x minus 2. Make sure that you're not missing any terms in descending order, like for the second term, or second power, first power, 0 power. First power, 0 power. Make sure you're not missing anything. Look at the very first terms. So I'm looking at 3x squared and x here. How many times will x go into 3x squared? That's 3x, because 3x times x is 3x squared, and you're going to distribute that through your divisor. So 3x times x, and then 3x times negative 2 would be negative 6x. And you want to subtract. That's going to give you 1x plus 1. And then, again, look at my first terms here. X times what gives you x? 1. After that, I'm going to have a remainder, but I don't care about that. I just care about my divisor. And so my slant asymptote is going to be y equals that divisor, which is y equals 3x plus 1. Now for number 18, it asks us to sketch the graph. I'm just going to use my calculator. Just give me a minute here to bring up Desmos. And we're going to put the equation in for number 18. The numerator is x squared minus 1. And the denominator is x cubed minus x squared minus 12x. So it kind of looks like we've got this crazy graph. What we just have is something with a bunch of asymptotes. Our asymptotes are, first if we look at this, the first terms, and we look at the exponents, we see that for at least the horizontal asymptotes, that n is less than m, which is going to give us a horizontal asymptote of y equals 0, which is just our x-axis, and we can kind of see that there. And then if I look at the denominator for my vertical axis, vertical asymptote, sorry, you want to factor that denominator. So I've got x cubed minus x squared minus 12x. I'm going to factor that. They all have a common term of x. So I'm going to factor out an x. Because I want to find out what values of x are going to work or not going to work. When I factor out, or when I factor my trinomial, I have x times x minus 4 times x plus 3 equals 0. I'm going to take each one of these factors, set it equal to 0, and solve, so I end up with x equals 0. That's this asymptote. I get x equals 4. There's another asymptote, and then x equals negative 3. Oops, I did the negative 3, sorry. X equals 4 is over here. So that's the graph of the equation. All right, number 19. For number 19, let me get rid of what we have up here. And this one is asking for direct variation. We actually have two things going on here. We have y varies directly as x, and inversely as the square root of z. So if I kind of forget about the x for a minute, when I do inverse variation, it's k over whatever's coming. So I'm going to put k over the square root of z. So it'll look like that. That's going to be my basic equation. Y equals kx over the square root of z. And then you'll substitute and find k. And then solve for y in the last section. Number 20, it's just another direct variation problem. The kinetic energy E of a moving object measured in joules. So E varies jointly as the mass and the square of the speed. So that variation problem is going to look like E varies jointly, so K times our mass and the square of the speed. And you just want to find your constant K and then solve for E. So same kind of problem as 19. The bonus, all you're doing is taking that graph and following the transformation. So you've got something happening to x. That's number 1. 2. 3, you've got a multiplier. 4 is your negative there. And that's a reflection. And then the 5th thing is to go up by 2.